So the next speaker is me, Nijso Beishuizen. I'm from the Technical University of Eindhoven and from Bosch Thermotechnology in Deventer, both in the Netherlands. And I will talk about a graphical user interface for the CFD solver of the SU2 software suite. So short introduction. The main library that I've been using is called TREM. Some words about the architecture, and then I will show a short demo on the laptop, and then I conclude with the next step in the development of this graphical user interface. So first of all, how do we run SU2 currently? Well, most of the people, I think, they just open the configuration file in an editor. They start SU2 either on the command line or using some submit script on a cluster. Then they open the intermediate results in ParaView to have a look at it. They probably find out that things are going horribly wrong. They stop the job. They go back to the text editor and they start it again. Now, about looking at the intermediate results, there's actually now a tutorial online on GitHub that shows you how you can do a real-time update of the ParaView solution and the residuals that are stored in the history file live in ParaView. So if you're interested in that, you can also have a look at that tutorial. But if you want more, then this presentation is for you. So an alternative to this approach, first of all, why do we want to have this alternative? Well, especially for starting users, let's say the learning curve is quite steep. Most people come from Windows. They have to learn how to use a Unix system. They have to learn how to set up the problem. There is no visual feedback. Usually they don't know which options they have to change. And yeah, it can take a while before a starting user is ready or feels confident that his case is actually solving what he wants to solve. And a graphical user interface can really help you set up a test case faster and with higher reliability. So that's for starting users. And for experienced users, well, probably many experienced users have their own scripts that they run all the time. And probably many users have basically the same scripts written themselves. And also a graphical user interface can be an interface for a couple of scripts that basically everybody is using and you know, reinventing the wheel all the time. So graphical user interface is not only for starting users, but can also be very useful for experienced users by coupling, let's say, more advanced capabilities to it. And it gives you, let's say, one environment where you can do the pre-processing, the running, the monitoring, starting and stopping a job. And the main goals for this graphical user interface are it should be easy to use for new users, so they should be able to set up and run a case in an easy and robust way. And we should be able to automate complex tasks. So for experienced users, basically perform complex tasks with a few buttons. But you know, writing a user interface, it turns out to be quite some work. So for now, I focus on the first part. It also has the word easy in it. Easy to use for new users. And what do I use for this? So I have looked around at I have checked out several options, and I quickly came out at TREM, which is developed by Kitware, which is famous from also developing ParaView, among other tools. It's an open source platform for creating interactive and powerful visualization analytics applications. visual analytics applications. It's based on Python and leverages platforms such as VTK, ParaView, Vega. And it's basically able to create web applications in a couple of minutes. Unfortunately, not a complete graphical user interface in a couple of minutes, but still it was very easy, very intuitive to use. As I said, it is being developed by Kidware, and you can also see the website below. Now, what does TREM claim? It claims to be simple. So all the logic and user interface definition can be done in plain Python. I found it very easy to work with. It's also very powerful. Well, we all know Python offers already many capabilities and libraries like NumPy, Matplotlib, VTK, ParaView. They all have Python implementations, and also it runs on basically everything that can run a browser. So TREM runs in a browser. So what is the basic architecture that I use for this graphical user interface? So here is a screenshot of the graphical user interface that I'm currently working on. So what did we see? So these are the main components. So there's the main menu bar on the top for loading and saving meshes. To the left, we have a Git tree with all the main options that we need to set for the configuration. There's a submenu for, let's say, the detailed information, and there's a main window, which is the rendering window showing the mesh, and it's also the location where any pop-up menus for even more detailed setup appear. Then the rendering window is actually not one window, but it can be a series of windows that you can access as different tabs. Currently, there are two: one for the main mesh and one for the history. So the residual plot that visualizes the residuals in real time. So currently, what you need to do is you have a mesh already available, an SU2 mesh. We basically convert it to a VTK format internally, and we work with that because VTK is really the backbone internally. Also, the configuration file is converted to a JSON file. Then we set it up. Then basically, when we want to run it, we write a new configuration file, and we just start SU2 as an external process. So let me just, I forgot that the arrows are animated. So the configuration file is given to the SU2 solver, and then SU2 writes files periodically. So the solution file, the history file, and these files are then being read by the graphical user interface periodically for let's say quasi real-time solution update. And another nice thing about this is that TREM supports client-side setup, where basically the graphical user interface runs locally, and also a server-side setup where you can access it over the internet, and everything runs somewhere, and you don't care about any kind of installation. You just upload your mesh and you go. Now for the interactive demo, I have to switch to my other laptop. So
give you presenter.
Yep.
So now I'm gonna say make presenter, and then you're gonna be asked if you can share your screen.
All right.
And then let's make sure we see your screen. Yeah. Okay, you're good.
So we don't see it in the audience yet. Or,
Yeah, we do. We see it.
yeah.
Wow.
We don't see it on the screen here yet.
It's hidden here. My fault.
So that's the
Yeah,
one.
there it is. Okay.
All right. So this is the graphical user interface. I'm moving a little bit closer to the mic. So as you see, I already started it. It runs in the Firefox browser. I started it locally on localhost. And what you can see is you see the main rendering window, where I have just loaded a very familiar test case, which we already saw before today. For the rendering window, there are already a couple of options. So we can switch the grid on and off. There's the bounding box, so you can see how large it is. And if you move it away, then where is it? Oh, let's move it back. And to the left, we have the main menu that well, it's, let's say, a classical way of setting up a CFD simulation. So we basically go from top to bottom through all the different options until we are ready for the final step, which is solving. So we have here the physics solver. We have here the scroll bar because of the options. So we have some main options, so compressible, incompressible. For incompressible, we can also switch the energy equation on and off. Not for compressible, we can switch to different turbulence models. For now, we just keep it to Spallet-Almaraz, and we also have the different submodels for Spallet-Almaraz, and also if we switch to different turbulence models, we have the other options available. Material options you can set here. So all the options are, or let's say many options are available, not all options. And here in the pop-up window, we can set let's say the details of the selected options. Then for the boundary conditions, you can also conveniently see where they are because they are highlighted in yellow in the window. We can put the inlets to an actual inlet boundary condition. And here we see the sub options. We have another inlet. I will just quickly set it up. We can also put it to another temperature. We can put the outlet to outlet. Here we have the outlet options. The axis is just the symmetry axis. And there are no other options for this. So that button does not do anything. We have the wall. We just keep it at 300 Kelvin. This is internal. Internal doesn't do anything. It just highlights what the internal setup is. Here we have initialization. We can, for instance, start from a restart file. This one, for instance. So we can see here the what we start with. We can also initialize with uniform conditions. And I have also already made some room to do patch initialization, so you can create more complex setups. File I/O, so every 10 iterations, I just save something. 1,000 iterations, let's see if it works. I will move this up a little bit. So here we see in the top right, geometry and history. Let's see if this runs. So currently there's no feedback, there's no internal, let's say, information about what happens. Oh, here we have the residuals. So as you see, it gets updated. So now I have to check, maybe I forgot something here. Okay, yeah, so here we see that, you know, there's a stream from left to right and there's a stream from top to bottom. Let's see, this is maybe not so interesting. Maybe, I think it doesn't, of course, you discover there's a bug at the moment that you give the presentation. Did I do that? Maybe, yeah, it's normal to the inlet, so that should be okay. Maybe I forgot something else. But in any case, you could see that there was an update of the fields. I just set it to a couple of hundred iterations. You can see here the residuals going down. And we also see that the temperature is stalling because this was the case where that Christopher talked about this morning, that currently if you have different temperatures and different heat capacities for the streams, then, or actually this one has constant heat capacities, but the temperature is stalling. So that's my short introduction to the graphical user interface. Now I have to check if I can go back to the final slide.
Should be stealing. So you're gonna lose it.
Yeah. So
let's get these up. Show screen. Good.
Yeah. All right. So these are some backup slides in case that things go horribly wrong. So next steps. So of course, there are still bugs. There always are. So that's of course one of the most important things to fix. So because if you are a new user, you just want to, you know, to set up a problem without any, without worrying about ending up with an invalid configuration file. Also, some documentation needs to be added to the websites. And what's very important is some validation for the configuration options. So internally, we work with JSON. So the idea is to have a JSON validator coupled to this. And then once the main functionality is working properly, then we can also add support for other solvers. So species transport, combustion, unsteady flows, multi-zone. It will be very easy then once the basics are there. And of course, some extension for real-time monitoring, like supporting all other information in the history variables, monitoring points, and multiple views in the viewing window. In the meantime, while you are waiting and you feel like also co-developing on the graphical user interface, please go ahead and download the current version from GitHub. let me know, and let's hope that we can make this happen sometime in the near future. Thanks for listening, and any questions?
Awesome, Nijso. So
Yeah,
I'll help just so you don't have to take our questions. Yeah, go ahead.
Yeah. So the options like hard coded for you that you do, or they're just like all one support?
Oh, sorry. So the question is if the configuration options were hard coded, or?
Yeah. Like, if you support the config options, like for specific items, or like all of them.
Yeah. So we basically read in an existing configuration file, and the options that are supported are read and used. And when we write the configuration file again, we just write the options that we don't support as they were, and the options that were supported, we write the, let's say, the new options. Yeah.
Okay. That makes sense. And then the other thing I was going to ask was for what was this? Yeah.
Okay.
Oh, Andrew,
So I just follow on the region and existing configuration file. So is it possible to generate a configuration file and this or leave it on your house?
You mean if you can start from scratch? Yeah, you can start from scratch. Yeah. I'm sorry, what's that?
like validation. You mentioned validation.
Yeah. So at the moment, there is no config option validation yet. But that's, I think, something that is important and should be in sooner or rather than later.
Okay.
Very nice work, I think. I tried one version of yours from your GitHub, but maybe we're not really sure at that point. But there was a lot of dependencies. So are you planning to reduce the dependencies so that the installation is a bit easy, or maybe we need your support for installation?
Yeah. So at the moment, probably forever, it depends on many libraries. And of course, as a starting user, you don't first want to find out which of the 35 libraries or so you actually need. There will be, what I found the easiest to work with is virtual environments where you just say, okay, run this command. It will basically install all libraries that you need for you, and you're good to go. Another option that I actually used for the demo is you basically pre-package all the libraries into, let's say, like a pre-compiled virtual environment. I used PEX for that, and you give that with the graphical user interface. I also work with Docker, but it's not available yet. Yeah, but yeah.
You mentioned that you have installed on the server. What about working with an HPC environment when you have some job scheduling handled by server?
Yeah, so the question is, how do you, I guess, monitor the job when you run it on some kind of server?
Anything to run it or put it in the queue or some queuing system. So I guess right now you start just
yeah.
Can you adapt the solver command you send?
Does that have to be local, or could you run this?
Yeah. So what we do, so the configuration that I have is I have, let's say, a head node or a visualization node where I also start my jobs, and this is also the location where I can start the graphical user interface. And on this head node, I also have access to the files that are written by SU2. So it doesn't have access to, information about where it actually runs and real-time information, but it does have access to the files that are being written periodically on the head node.
Could you change the command you send in the backend to the backend that instead of just whatever MPI run local? Could you
Yeah, sure. So for now, if I press play, it just starts MPI run. But of course you can, it's just one line of code. So of course that should be extended to be more flexible, and you should basically be able to glue a submit script to that. Yeah.
How much of the logic that we have in the conflict do you end up having to proceed to create the interface? Like the knowing from the options that you selected already, the UI,
Yeah.
the ones that keep on active next, how much of that?
Yeah. So at the moment, I don't read, let's say, any information that is already in the, let's say, SU2 files. So basically, I have to copy the entire, let's say, validation that is actually also already there in SU2. So my vision is that when we have, let's say, a JSON validator, we can use the JSON validator for both SU2 and the graphical user interface. I think that's also easier to maintain. But yeah, that will be a couple of weeks before we have that.
Try to get it down to one validator.
Other questions?
I think everybody's impressed.
Yeah, Afshan?
Kind of a suggestion, but for maybe the fluid stuff, like CFD and all that other stuff, like maybe an interesting kind of feature, like make it easy to put options in, so you actually select the fluid and just say like something like pressure, temperature, and use like cool prop to kind of fill the rest.
Yeah, because now you have to basically select, if you want air or whatever, you have to select the density of air, etc. But yeah, if you have cool prop or other tools, you should be able to say, okay, I select air and I get all the properties. Yeah, that's so yeah, let me know when you have time to implement it. Oh, you did it. Okay, that's great.
There you go.
Whatever condition you can derive, like you can get like enthalpy and whatever.
Yeah, great. Yeah, let's do it.
Okay, we better stop here. We're time for break, but let's thank Nijso once again for a nice presentation.